Well, g'day flatties and globe defenders. This is Critical Think from Down Under. Today we look at another Exploring the Plane production. This video entitled Is a Photo Always Accurate? A recent video. And the claim is that cameras sometimes lie. Well, I hope Exploring the Plane has severely chastised his camera for lying. I think mine will do just fine. I'm not accusing my camera of lying. But anyway, we'll address this because Exploring the Plane is using this as evidence for the flat Earth. So we should look at this. So in summary, really, for this, it's Exploring the Plane is saying, I don't understand optics, therefore the Earth is flat. So this is typical flat Earth argument. And we'll get into this and examine it more closely. Just a little aside, I noticed that from another video there's this notice. And it says, any comments made which do not support flat Earth will be disallowed. Doesn't that seem to be a little bit at odds with your claim that you've never blocked anyone? I don't know, but anyway, why put this up then? I notice you're saying you're only willing to question the mainstream narrative and they're the only people that are welcome, but anyone who wants to question the flat Earth narrative, they're going to be disallowed. There should be some alarm bells ringing right there in anybody's head who's got the right head on their shoulders. This channel unashamedly promotes flat Earth and it no longer tolerates unfounded theories such as light refraction for the excuse of seeing too far on a globe. Right, so light refraction is an unfounded theory. You probably meant to say that atmospheric refraction is an unfounded theory. But anyway, you've said light refraction. So do you realise, of course, that a camera depends on light refraction? The glasses that I'm wearing, they depend on light refraction. I mean, people understand how light refraction works, you know. And this little demonstration, you know, light refraction in a density gradient, light bends. How about that? The atmosphere has a density gradient. Therefore, light bends, which is the same thing. It's another name for refraction. Refraction causes light to bend. Have you got that? Right, so ETP is quoting from this book, Curvilinear Perspective. I did try to find a copy of this book, but I find it's a little bit old and the only copy I could find was a little bit expensive. Now there have been some more recent editions as of maybe 40 years ago, but never mind, I couldn't actually find a copy. We know that distant objects appear smaller due to their angular size. Well, it's not the angular size so much that causes them to appear smaller. It's the fact that as they get further away, they subtend a smaller angle in the field of view, and consequently they appear to be smaller, and that gives them a smaller angular size. I mean, not technically incorrect, but I would word it a little bit differently. How should this scene look to the naked eye? Well, I must admit I don't often stick my nose into a brick wall to see how it looks like. But anyway, I did do this experiment myself with my eyes just to see what's going on here. And according to this, the red lines are significantly further away than the green lines. Correct. So the red lines, being much further away, should appear noticeably smaller than the green lines. Correct. And they do. If I go and stick my nose up against a rectangular object and just very carefully try to look at it all at once, or maybe even just glance a little bit side to side, yes, you can tell that the sides do appear smaller, but we never notice because our brain knows that, that's the shape of the object we're looking at, especially if it's a wall in front of our house. But anyway, the brain does make some adjustments for what it sees. Yes, indeed, that is known. So surely we should see something like this with the red lines smaller than the green lines. Yes, well, I verified that I can see something like that if I stick my nose up against a rectangular object. But if I'm a little bit further away than normal, then it's sort of like very hard to notice it. So after all, objects further away should be smaller. They should appear smaller, yes, and this is the test that he's designed. So a simple wooden rectangular frame with those distances 80 centimetres away from the wall, and the camera, when he takes a photo, surprise, surprise, it looks like a rectangle instead of the sides being squashed. So what's gone wrong with our prediction? Well, what's gone wrong with your prediction is you don't understand how a camera works. You don't understand optics. And yes, our brains do transform shapes, and we know that they're rectangles, and there's a whole pile of optical illusions that you can do that trick the brain. Yes, we know that. But a camera is not a brain. Cameras override the rules of angular size and produce a shape similar to that made by our brains. Well, no, that's not quite correct. The two mechanisms are entirely independent. Most cameras these days have a rectilinear lens, so that objects that are rectangles appear to be rectangles. This is deliberate by the makers of the camera, because normally when you're looking at a photo, you're not looking at it with 100 degrees field of view. You've normally got the photo directly in front of you, and it would look extremely weird if the rectangle looked like how we showed it before. So to avoid complaints, the manufacturers of lenses made a straight line appear to be a straight line in a photograph. Just imagine if they didn't do that. Just imagine if everything was a fisheye lens. People would be bringing their cameras back to the shop. Whoa, this one's broken. I taken a picture of me wall from 80 centimetres away and it's all curved. The wall's not curved. It's straight. I want my money back on my camera. Not only that, could you imagine the outcry from the flat earthers if cameras took pictures like that? They were curved. Oh, cameras have curves in them. That's why the earth is curved. It's just the camera. Oh, we already get that already, don't we? So now flat earthers are complaining that a camera takes a picture of a straight line and it's more or less straight. Our world is linear. Don't know what that means. The world which our eyes see is full of curves and obtuse angles before our brains straighten it up. Yes, that is true. But when you actually focus in on a very small field of view, it actually looks straight. That small field of view looks straight because the angles are small. Therefore, in that small field of view, everything appears to be similar size and straight lines. In short, a camera processes the image like our brains. A photograph may be not true to reality after all. Well, no, the camera does not actually process the image. They construct the lenses in such a way that rectangles come out as rectangles. And they do this so that a photograph may appear more realistic. Because if you were to take a photo of something like the previous one we've seen there, where everything was curved lines, you would say that that doesn't really look as realistic as the one that was taken and all the straight lines come out straight. So a photograph is actually quite true to reality because of the optics and the law of refraction. You know, photographs rely on refraction, that thing that you say is unfounded science. Right. So here's a section of that other photograph that had all the curvy lines in it. You see in a small field of view, there's not really curvy lines. It looks pretty much straight to me. The other thing you've got to notice here is that if I step back from the wall, instead of being 80 centimetres away, I would be 8 metres away and look at the wall. Then I wouldn't notice any difference at all. The two sides would be 99.4% in terms of size of the centre. So you wouldn't really notice that at all. And now you must remember that we're taking pictures of things that are like 50 miles away, 80 kilometres. So what this is called is perspective distortion just won't exist because the angles are so small. So I did my own tests, and I've got two renderers. This one is Povray, and I've got the perspective render there, which is pretty much close to a rectilinear projection. So you can see here that the side pieces don't look exactly like cylinders. They've got slanted ends and things like that. However, when we render this far away in a small field of view, it looks perfectly okay. It looks like three poles, and this is how you would expect to see it. Then I did a render with a fisheye transform. Povray has a number of transforms you can select. Clearly you can see that this one is suffering from perspective distortion because I've simulated here the same field of view, 100 degrees field of view, and the edges are curved and the side poles are smaller, about 2/3 of the size. So this corresponds to the 80 centimetres from the wall type of situation. Now, still using the fisheye lens, we zoom in a very long way away, three same size poles, and you look at that. There's no perspective distortion because the angles are so small. The distance to the side poles is so close to the distance to the middle pole. So there's no perspective distortion. So even with the fisheye lens, when you're zooming in, it's going to be an accurate representation. Now this renderer from Science It Out, it's a ray tracer again. This is not designed for use for close-up renders like this, and because of this obvious reason here, this renderer takes some shortcuts so that we get a picture quickly, and this is very good for the type of work that we're doing with long distance landscapes. So you can't use it up close, so it distorts up close. But once we get far away, I've made these poles quite big, quite tall. You can see that looks perfectly normal, like you would expect to see three columns sitting there, all the same size. So you see, this perspective distortion is not a factor. It doesn't affect your long distance observations. On top of that, I did another experiment where I took a picture of a ship which is 12 kilometres away, and I worked out the height of the ship. There's another video about this, but I worked out the height of the ship based on the height of the containers on the ship, and the height of the ship worked out to 48.2 metres, and because it's about 12 kilometres away, then its angular size is known to be 0.228 degrees. So there it is. That's how you work out the angular size. And then I took the photograph, and using the known dimensions of the camera sensor and the focal length, I worked out that on that photograph the ship was 0.228 degrees. So the angular size in the photograph matches exactly with the angular size in reality. How about that? Summary: cameras work just fine. Pictures taken with a camera are immediately recognisable as being a good representation of reality. Rectilinear lenses were invented to make straight lines appear straight. Perspective distortion is not a factor at small field of views in landscape photography, and measurements taken from a photograph are easily verified as matching demonstrable reality. So, no problem with cameras at all. Sorry, flat earthers.